All right. We are going to talk about order of operations. And specifically, we're going to talk about exponents and absolute value. So the order of operations, first of all, you have four basic operations. You've got addition, subtraction, multiplication, and division. Those are your basics. There are more operations than that because I can take square roots of things, so that's an operation. I can use exponents, so those are operations. I can take cubed roots. I can do all sorts of stuff, but your basic four functions are addition, subtraction, multiplication, and division. So for order of operations, we have told you your entire life, absolute value is an operation, that you can use PEMDAS, or please excuse my dear Aunt Sally. And P is going to stand for parentheses, but I'm going to change that into grouping symbols because we've got more than just parentheses at this point. So if I've got a grouping symbol, like hard brackets or a square root, you would have stuff underneath the square root that's grouped together. A fraction, you could have a numerator that's grouped together and a denominator that's grouped together. So pretty much any grouping symbols will be done first. So I work from the inside out. Then I've got exponents, and they're next. So I need to take care of exponents. Multiplication and division. And these are a package deal. So if you see multiplication and division simultaneously, you need to work from left to right. You need to work from left to right. And then the last ones are addition and subtraction. Same thing. If you see them subtraction. If you see those simultaneously, you need to work them from left to right. And honestly, order doesn't matter with addition and subtraction, and it kind of sort of doesn't matter with multiplication, but for us to be consistent, then we're just going to say if we see multiplication and division occurring at the same time, wherever we're at in the simplification, we're going to work it from left to right, and then same thing with addition and subtraction. So now that we know how to do these order of operations, this is the order in which we do them. We'll tackle grouping symbols first, and we'll work within the grouping symbols, and we'll attack it this way. So we need to look at exponents real quick and figure out what an exponent is. So to give you an example, if I have 4 to the third power. All right, so let's pause for a second. Multiplication is a shortcut for repeated addition. So if I say 4 plus 4 plus 4, that's 12. Or I could say I had 4 added to itself 3 times, and that's 12. So multiplication is a shortcut for repeated addition. Division is a shortcut for repeated subtraction. Exponents are shortcuts for repeated multiplication. Okay, so we call the base is the big number. So that is your base. Your exponent is your power, or your exponent. And it's a little tiny number up and to the right of the base. Okay, it's called a subscript or a superscript. And so it tells the font to be up and to the right of the base. And what it does is it tells you how many times to use that base as a factor. So I would say 4 times 4 times 4. So I'm going to use my base 3 times multiplied to itself. Okay? So it's repeated multiplication. So 4 times 4 times 4, I'm going to find out is 64. So that is the process that we are working with as we go through this. So I'm just going to give you a few examples as we work through. And I always want to kind of give you a heads up in case you run into something weird. So we already know what an exponent is, and we know how to identify it, and we already know how to work it out. So if I have like 5 to the third, that is the same thing as 5 times 5 times 5. And on your calculator, you will have an exponent key, and it should look like this, which you call a caret, or it may say x to the y, something like that, but you will need to find your exponent key. Because what I would do on my calculator is do 5 raised to the third, and I would find out that that is 125. So, looking again, let's try 2/9, and I'm going to raise that to the third power. Now remember, math people like fractions, so I'm going to leave this as a fraction. I'm not going to change this and do a decimal. And what I do notice is that this exponent belongs to the numerator and the denominator. So what that means is 2 times 2 times 2 over 9 times 9 times 9. So 2 times 2 times 2 is 8, and 9 times 9 times 9 is 729. Okay, I'm making sure that I don't screw that up. All right, now, do I need to reduce 8 over 729? No, because it didn't reduce over here. It's not going to reduce over here. So my answer for that is 729. So now I can do another one. So let's use some decimals and say I've got 0.07 raised to the fourth, and I'm going to go grab my calculator. All right, so what I have, pardon that mark right there, is, well, forget it, it's not coming off. All right, so I've got 0.07 to the fourth power. So in this case, my exponent key is right here. Okay, so I've got 0.07, and I'm going to raise that to the fourth power. And what do I get? I have 1, 2, 3, 4 zeros followed by a 2401. So 1, 2, 3, 4, 2401. Okay, and that's your answer. So now we're understanding the power of powers. So they get kind of big really fast or kind of small really fast, and so that's why we like exponents. They are shortcuts for repeated multiplication. So what happens now, we're going to dive into some order of operations. I've got a 4 times a 3 minus a 12 divided by 3. So when I look at this, I've got 3 things going on. I've got multiplication, I've got subtraction, and I've got division. Well, I know with multiplication and division, if I have it present at the same time, I need to work it from left to right. So what I'm going to do first is I'm going to do the multiplication, and then I'm going to come over here and I'm going to do the division. So I do know that 4 times 3 gives me 12. This minus, or this subtraction, is coming along for the ride. And 12 divided by 3 gives me 4. And so now my huge mess of a problem just got reduced to a simple subtraction problem, and 12 minus 4 happens to be 8. So using proper order of operations gives me an answer of 8. So let's try another one. I have 84 divided by 7 times 2. So this is why this is coming up, because in PEMDAS, multiplication comes before division. But when we have multiplication and division present at the same time, I work it from left to right. So I need to do this one first. So 84 divided by 7 is going to give me an answer of 12. So that part turns into a 12. And now I can move on and address the rest of the problem. So that leaves me with the 12 times 2. So again, it didn't matter that I had multiplication last. I need to work it from left to right. So this gives me an answer of 24. Okay, you'll notice if you had done it backwards, you would have gotten 7 times 2 is 14, and 84 divided by 14 would have been something that is not 24. So order is very, very important. So let's try another one. I have 1/5 times 3/2 plus 4/3 times 1/2. So what do I notice? I notice I've got a multiplication problem, and I've got another multiplication problem. And multiplication is done before addition is done. So I need to go ahead and do my multiplication first. So I'm going to see if I can reduce anything. I can't. So 1 and 5 don't reduce. 1 and 2, 3 and 5, 3 and 2. So I'm just going to multiply straight across the top and straight across the bottom. And then same thing over here. Oh, wait, that reduces. So that's a 1 and that's a 2. So what I did was I took that 4 and it's a 2 times 2 times 1 and a 3 times a 2. So one of those 2's reduced. So that left me with a 2 times 1 and a 3 times 1. Okay, so straight across the top gives me a 2. Straight across the bottom gives me a 3. So you'll want to start saying, all right, both of those are divisible by 2. I can do that in my head. So 4 divided by 2 is 2. 2 divided by 2 is 1. So really and truly, you just divided out these 2's. All right, now I've got addition. I need a common denominator, and my common denominator is going to be 30. So he needs to be a 30, and he needs to be a 30. So how do I change from a 10 to a 30? I multiply top and bottom by 3, which gives me a 9. How do I change from a 3 to a 30? I multiply top and bottom by 10. So that gives me a 20. And now 9 thirtieths plus 20 thirtieths gives me 29 thirtieths. Okay? So let's try another one. We've got 56 plus 32 divided by 8 times 2. So I'm looking at this. I see addition. I see division. I see multiplication. So multiplication and division take charge, and I need to work it left to right. So I see that part first. So I have a 56 plus that yellow part turns into a 4, and the times 2 is going to come along for the ride. And so that yellow part is now my 4. Well, now I've got addition and I've got multiplication. So I did my division and multiplication left to right. So 4 times 2 is going to give me 8, and 56 plus 8 is 64. Okay? So, a couple more problems. We're going to do, I'm looking for interesting ones. All right, so I'm going to evaluate. So I have 3p squared plus p, and I'm going to evaluate it for p equals 9. So this is how we started you in algebra back in elementary schools. We started making you do these little substitutions. So basically I've got a 3p squared plus p, but I'm going to substitute. Wherever there's a p, I'm going to put a 9. So this p, this square belongs to that p, so I'm going to swap it out. So I have 3 times 9 squared instead of p squared. And then I have plus p, but instead of p, I'm going to put a 9. And now I'm back in a situation where I need to do order of operations. So it says parentheses first. The purpose of the parentheses were for me to determine what that exponent is attached to. I really didn't need the parentheses. Okay, but how is this whole thing connected? This is 3 times 9, and this is 9 squared. So I'm supposed to do exponents first. There's nothing to be done in the parentheses. So now I'm going to move on to exponents. So that gives me 3 times 81 plus 9, because 9 times 9 is 81. 3 times 81 is going to be 243. Okay. So I've got 243 plus 9, and 243 plus 9 is going to be 252. So work it in order. Do your substitution first, and then we'll work it in order. So another one we have, and I'm just going to make this a longer video again. So I've got a 5x minus 3 over 3x. And I'm going to substitute that if x equals 2. So wherever there's an x, I'm going to put a 2. So how is this combined? This is multiplication. So I have a 5 times a 2 minus 3 over 3 times there's another x. So I've got a 3 times a 2. So this is another situation where we've got grouping symbols that aren't so obvious. I've used this fraction bar to group my numerator together and again to group my denominator together. So if I look at just the numerator, I have a 10 minus 3, and then that becomes a 7. If I look at my denominator, I've got 3 times 2 is 6. So that becomes 7, 6. So you're grouping the top and you're grouping the bottom. Okay? So let's find some other exciting ones. All right, let's group twice. So if I have 6 times x plus 3y, if x is 9, and if y is 5. So now I know what x is 9, and I know what y is 5. So I'm going to substitute in. So how is 6 joined? This says 6 times, and so the parentheses are indicating multiplication, but I also have stuff to do on the inside. So my x becomes a 9, plus 3 times my y becomes a 5. So looking on the inside of the parentheses, is there something I know how to do? Yeah, I know how to multiply. So that becomes 6 times 9 plus 15. Is there still something I know how to do inside the parentheses? I can add those. So 9 plus 15 is 24. And now 6 times 24 gives me 144. So you want to work from the inside out. Okay? And then, let's do that one. All right, so we have 2x plus 2y minus 3 over, this is going to be a long video, sorry. I should have stopped it a while ago. If x is 3 and y is 1. So the first thing I'm going to do is substitution. So wherever there's an x, I'm going to put a 3. Wherever there's a y, I'm going to put a 1. So I have a 2. This is multiplication. So 2 times 3 plus 2 times 1 minus 3 over 2 times 1 plus 3. So again, I'm going to work at just the numerator first. So this is multiplication, addition, multiplication, subtraction. So I need to do all the multiplication first. So that gives me 6 plus 2 minus 3. And on the bottom, I've got multiplication and addition, so do multiplication first. So that's 2 plus 3. And now I can work it from left to right. So 6 plus 2 is 8, minus 3 is 5. 2 plus 3 is 5, and any number divided by itself is 1. Okay? And now what we want to do is look at some absolute values. So this is another type of grouping symbol. An absolute value simply means distance from 0. Okay, so distance is always positive. Distance is always positive. So my brackets are tall vertical bars. And what this says is, tell me what the absolute value of negative 8 is. In other words, how far away is negative 8 from 0? Well, if I put it on a number line, here's 0, negative 1, negative 2, negative 3, and I can go all the way on to negative 8. So that is 1, 2, 3, 4, 5, 6, 7, 8 spots away from 0. So how far is negative 8 away from 0? It is 8 spots. So I do the inside first. There's nothing to be done on the inside. Then do what the brackets say. Okay, so whatever's on the inside will go positive. So let's try another one. I have negative absolute value of 5/4. So do what's on the inside first. There's nothing to be done because I like this in fraction form. So move out. This says, what is the absolute value of 5/4? How far away is 5/4 from 0? It is 5/4 away. So that part stays positive because distance is always positive. And now I find out that this negative is coming along for the ride. So the negative is right here, but I did order of operations. Okay, so 5/4 stayed as a fraction. The absolute value of 5/4 is positive 5/4, but this negative is coming along for the ride. Okay, so let's try negative 4/7. So I'm going to work from the inside out. So can I do anything with negative 4/7? Nope. He is in fraction form. Leave him alone. What is the absolute value of negative 4/7? The absolute value of negative 4/7 is positive 4/7. So that negative 4/7 becomes positive 4/7 because it's distance. And now this negative is coming along for the ride. So your answer is negative 4/7. So let's try another one. I've got the absolute value of 12 minus 2. So work on the inside first. Can I do that? Yes, I can. It is just subtraction. What is 12 minus 2? It is 10. So now I've got the absolute value of 10. How far away is 10 from 0? It is 10 units away. So whatever's on the inside, you're going to make it positive. Okay? And then last one, and we'll be done with this section, we're going to do kind of a mix of stuff. So I have evaluate 4 times the absolute value of x plus 5 times the absolute value of y if x is 2 and y is negative 8. So I'm going to do substitution first. So wherever there's an x, I'm going to put a 2. And wherever there's a y, I'm going to put a negative 8. So I have to do order of operations first. So that means parentheses or grouping symbols. So there's nothing to be done on the inside, but I do know what the absolute value of 2 is. What is the absolute value of 2? It is 2. So that becomes 2 plus, work in the grouping symbols. There's nothing to be done with negative 8, but I do know what the absolute value of negative 8 is. It's 8. So that turns into 5 times 8. So this is my new expression. So now I've got multiplication, addition, and multiplication. So I'm going to do the multiplication from left to right. So 4 times 2 is 8. 5 times 8 is 40. And then I can add, so I get an answer of 48. And that is it for this section.